Yeah, maybe can we start now? Okay, so hello and welcome to our online lecture series. Our speaker today is Dr. Louise RAYNE, and she will talk about the landscape archaeology researching ancient farm. So Dr. Louise RAYNE is a fellow of the Newcastle University Academic Track Fellowship Scheme. Before that, actually, she was a research associate at the University of Leicester on the endangered archaeology of the Middle East and North Africa project, EAMENA. Louise actually undertook her PhD in the geography and archaeology departments of Durham University in applying remote sensing to record former water management system in the Middle East. She has undertaken fieldwork in Syria and Morocco. She is actually a specialist in remote sensing, photogrammetry, GIS, landscape archaeology, water management archaeology, archaeology of the Near East and North Africa. So please, Louise, you can start now.
Thanks very much, and thanks for inviting me to give this recorded presentation. I'll get straight into it then. I'm going to talk today about landscape archaeohydrology. So researching ancient farms, or perhaps more specifically, researching the water management systems that supported those farms. And as Jafar says, I'm a research fellow at Newcastle University. Do tell me if there are any problems with the slides or sound. So today I'm going to give you a bit of the background to my current project, talk a bit about what archaeohydrology is, how that what implications that might have for future challenges, but then illustrate it with hopefully lots of interesting case studies from Mesopotamia, for example, Eridu. And then I'll sort of finish up by talking about what the implications that were for, later water management and so on. So for my current project, for my research fellowship, I'm looking at oases as hydraulic landscapes, and I'll come on to more on what those are in a minute. I'm looking at what the impact of anthropogenic climate change and pressures on water resources will be on those landscapes. We know this can be significant, it's going to be significant, but there's not actually enough knowledge of traditional water management that created many of those environments. And there's a risk that those places will degrade beyond viability before their potential for future sustainability can be understood. So my project is trying to address the gaps in our knowledge of traditional and ancient water management, trying to understand what made those places water secure. So to do that, I'm recording and mapping the locations of past and present water management and oases in the Middle East and North Africa, what their hydrological environments were, what types of water technologies they were using, and so on. Today, I'm going to talk to you about my work in the Middle East rather than North Africa. So archaeohydrology. There's a few key concepts which sort of underpin this sort of emerging discipline and idea, and it draws from lots and lots of other subjects and disciplines, so including those from within archaeology itself, such as landscape archaeology and geoarchaeology and so on, but also outside areas of scholarship, so engineering, hydrology and hydrological modelling, sociology and so on. In some cases, enough information can be gathered using the skills from all these different disciplines. Information can be gathered about past water management systems, that quite complex modelling can be undertaken to try and explain and quantify their potential productivity of those agricultural systems. But that's not exactly what I'll be talking about in detail today. So another key concept that if you're into ancient water management, you've probably come across at some point, is Wittfogel's 1957 hypothesis, that water management directly led to the development of early states, and this has often dominated discussions of past water management. However, more recently, research has shown that the situation was far more complex. Wittfogel's model is not fully grounded by archaeological evidence, and it leads to a need for more comprehensive and scientific study, which hopefully projects like ours are going some way to addressing. So I developed the hydraulic landscapes concept in collaboration with my PhD supervisor, Tony Wilkinson. And this concept describes environments created and modified by human action as a way to control water. So at first glance, a hydraulic landscape, it might look like this: a total tangled mess of channels, various dates and sequences, different sequences of abandoned and reuse. Just by looking at this, it's chaos. We don't know what's going on here. But by taking an interdisciplinary approach, we can sort of start to untangle this mess, taking this archaeohydrological approach. So we draw on lots and lots of different data sets to do this. So remote sensing in particular has made it much easier to study irrigation systems as a whole. A bird's eye perspective allows each part of the system to be investigated, including abstraction, transport, delivery to the fields and drainage. Sometimes layers and sequences of canals can even be identified amongst this. Of course, aerial photography formed the methodological basis of the image interpretation approaches taken by many archaeologists now. And historical aerial photographs are still very useful, but its coverage is patchy. So declassified imagery from Cold War United States satellite programs has become a really useful data set for mapping water systems. We'll look at many examples of it throughout this presentation. In particular, the corona missions from the 1960s have been useful for mapping in the Middle East. But its data wasn't declassified until 1995. Now it's panchromatic, black and white, with a resolution of up to 2 meters, which is actually pretty good and sufficient for identifying many irrigation features and other archaeological sites. So what type of thing are we mapping for satellite imagery and what can we see? So often ancient water systems may consist of a sort of open water gravity flow system like this, where you have some sort of abstraction point from a stream, river, a main channel, and then you'll have offtakes or laterals, series of laterals coming off this, and smaller channels delivering water to the crops, to the fields. This very smallest level of channels may not be visible in all or many images. But we also have underground features which collect groundwater where it's available and transport it to a cultivated area, such as an oasis. So we can call these canats or fogaras and so on, depending on where you are in the world. There are lots of different names for these features, but they have this quite distinctive sort of pattern of maintenance, construction shafts here. And we'll have a look at a few of these in this presentation. And often, we're looking at an archaeological example, a disused example of channels. They can be quite eroded and infilled as well. They can even be quite flat, depending on what processes have affected the remains of that channel since it went out of use. So just to give you an idea then of what the canats look like, we should do this process of making image interpretation key so that when we're doing our mapping, we're doing it in a standardized way. So you can see this example here of a canat or fogger from space, a very distinctive feature, and what exactly the same feature looks like on the ground. So we can use these for our mapping. Of course, a significant problem in the field of archaeohydrology is the lack of scientific dating. Many irrigation features are mapped using remote sensing or during brief field visits, and they're assumed to be a particular date due to their association with archaeological sites nearby. But even when water management channels are excavated, it's often hard to find material for radiocarbon dating, although sometimes they can be recovered, as in this example here. So in this case, shells were recovered. Recently, the technique of OSL, such as in this example here on the right, is also being used. So it can be measured when sediments were last exposed to light. And also we should use textual evidence and evidence from inscriptions linked with water management. And the original texts aren't always comprehensive. May simply mention that canal construction took place. However, Stephanie Ross has made detailed investigations of the textual evidence of water management in southern Mesopotamia. She's been able to reveal aspects of water management which are not cleared just from remote sensing or survey. For example, how allocation and maintenance strategies were carried out and the degree of the involvement of the state in irrigation. So we can contextualize archaeohydrological studies in the light of future challenges by recognizing to what extent past water management might have been sustainable and long-lasting. For example, the latest IPCC report recognizes the value of diverse forms of knowledge in dealing with climate change, such as scientific as well as traditional indigenous knowledge. Unfortunately, increasing climate extreme events have exposed lots of people to food insecurity and water insecurity too. So unsustainable agriculture and expansion of that, increases human vulnerability to climate change. Now, irrigation is effective in reducing drought risk and climate impacts in many regions, and it has many benefits, but it needs appropriate management to avoid potential adverse outcomes, such as accelerated depletion of groundwater and increased soil salinization. For example, Iraq, to deal with this, has a climate change national adaptation plan in progress, focused on achieving the Sustainable Development Goals, SDGs. Because Iraq is highly vulnerable to the impacts of climate change, including things like heat waves, drought, and dust storms, which damage crops and lead to desertification. As does a reduction in availability of surface water, and this also leads to desertification. So just to introduce the sort of study area I'm talking about today, I'm talking about the drainage basins of the Syrian and Iraqi parts of the Euphrates and Tigris. This is a project area in Mesopotamia. So these rivers and their tributaries provide water for irrigation. And today I'll be jumping back and forth between different locations and case studies throughout this large region. So in northern Mesopotamia, then, some rainfed cultivation is possible. But some of the earliest known irrigation systems are in southern Mesopotamia, where rainfall is much lower, less than 200 millimeters a year. So it's seen as being, underneath the limit for rainfed agriculture of around 200, 250 millimeters per year, which is often defined as the amount of rainfall needed when it's used as the main source of water for agriculture. Although there is this sort of marginal zone sort of around in between that area where things are very variable. The sort of lines, if you think about lines of or pixels of rainfall data, it's not static, especially in the sort of marginal zone. So although conditions could have been a little moister, for example, in the 6th millennium BC, rainfall patterns from this period into today can be assumed to be fairly similar to those of today, similarly variable, although conditions may have been a bit dry at different points. We'll also talk about southern Mesopotamia today, an area dominated by the Euphrates and Tigris rivers, which shifted course over time, for example, in the 4th and 2nd millennium BC, which could leave some canals dry. So episodes of dredging work could be carried out. So as you can see, the gradient of the plain in the south is really flat, so this is based on elevation models. And this can lead to sedimentation. So to take water off and transport it along the plain, the canal level needs to be higher up. Because of the flat gradient, natural levees build up with the rivers flowing along the crest of the levees. And it's easy then to just take water off the slope to get a more gradient. Now, these particular conditions led to a very particular development of water management, known as a crevasse play. So research into the long-term development of ancient water management is presented in our paper in Water History from 2015. I've just slightly lost my screen. There it is. So water was taken off by early irrigators just by diverting it off the levee slope, like this example here. So just getting that bit of gradient. And gradually over time, this would create a sort of fan of sediments, the crevasse splay. So this can be created naturally or by humans, and it supplied small areas of land for a farm or two. Eventually, these could be formalized into a more regular layout of canals. And these early forms of irrigation in Mesopotamia could eventually be formed in a sort of herringbone pattern, with canals taken off at right angles to the levee channel. And it's possible that early irrigation may have been organised locally, with small communities using and maintaining each channel. So here's where the ancient farms come in. So archaeological evidence suggests that irrigation was being undertaken as early as the 6th millennium BC, with crevasse splay style irrigation supporting farms and new urban centres in the 4th and 3rd millennium BC. Archaeologists have long recorded irrigation systems across Mesopotamia, especially using aerial photographs, satellite images, survey to map the distribution of channels in relation to sites. Elevation models are also now being used to explain the hydraulic context of irrigation systems. Interdisciplinary use of archaeological, textual, and remote sensing evidence is increasingly explaining the development of water management in Mesopotamia. So Adams argues that shifts in water channels, possibly caused by irrigation, cause irrigation systems to dry out and new ones then to be constructed. Larger scale canals are constructed during the 3rd millennium BC, but older systems would and could be regularly revitalized and reused. Rost explains the textual evidence for royal intervention in canal construction. Inscriptions mention that rulers built a particular canal, for example. She argues that the constructions of the 3rd millennium were often herringbone systems, quite modest, just taking water off levees with short canals. But from the 2nd millennium, larger scale systems increased, and during this time, documents describe works taken or sponsored by Hammurabi. Textual evidence in particular helps to explain how ancient systems were administered. In some cases, staff could be employed for this purpose, or land was leased out to farmers. While the main canals might be maintained by the state, but local irrigation may have been managed more locally by local officials, although sometimes with interference from the state. This type of administration ensured that work was done to clean canals, and that if necessary, workers would be hired. So research published by Athens in 1981 and built on by others since identified alignments of third millennium and later sites alongside possible former channels in the central plains of Mesopotamia. Excavations of a levee undertaken by Tony Wilkinson in 2003 near Nippur identified material dating to the 4th and 3rd millenniums at its oldest deposits. Sasanian and later Islamic materials were found near the top, and the levee was then abandoned. This shows that the levee was in use or reused over a significant period of time. And the longevity of some of these examples shows that they may have actually been pretty sustainable. So although herringbone systems may have been in use, or early systems in use, at least back into the 3rd millennium BC, more scientific dating evidence is needed to date the chronology of the development of irrigation in Mesopotamia, and to understand how resilient these irrigation systems were. It's likely that many of the earliest crevasse-based systems have been destroyed by erosion, sedimentation, and modern land use activity. So for this reason, we constructed an interdisciplinary study of water management around the site of Eridu, using remote sensing, field survey, and scientific dating. The water systems here consist of several crevasse plays and canals fanning out from a relic course of the Euphrates. This course may have shifted in the 2nd millennium BC. So this is a project funded by BC, work done by myself, Jaffa Jaferi, and Michelle de Grucci. So the site of Eridu itself, you can see here, has early origins in the 6th to 3rd millennium BC and continued into the 1st millennium. It consists of several mounds. It was the location of an important shrine since the pre-Ubaid period, which seems to have persisted even when occupation was more limited. And the shrine was periodically reconstructed and rebuilt. Some small-scale excavations were undertaken by the British Museum, but more extensive excavations were undertaken by the State Organisation of Antiquities and Heritage in Iraq in 1946 to 1949 to investigate the main mound and the smaller mounds nearby. Some investigations of the landscape were carried out at the same time. So the presence of freshwater mussel shells, and the low-lying position of the area was mentioned, and it was suggested that the site was situated in a marshy area, where resources such as fish likely to have been important. The remains of barley and date stones were recovered as well. Perhaps these were what was being cultivated by some of the farms here, which were using crevasse play irrigation systems. So you can see some of these systems here mapped onto the imagery. So with Dr. de Grucci, I mapped the channels around Eridu using a satellite imagery. So they're clearly visible as darker lines where there's sort of moister soil. And you can see here a crevasse play. It stems from a relic channel of the Euphrates here. It flows towards the north and divides up into many lines of channels. At the same time, there seems to be a system of gridded channels also stemming from it. So there may be a few different irrigation systems of different periods in amongst this. So careful image interpretation to separate channels from each other was combined with modelling of the angle of degree of the channels. And you can start to see by doing this that perhaps separate systems start to become more distinct, and even sort of very distinct groups of crevasse plays, for example, here, but also here and here. There seem to be several separate crevasse plays stemming from the Euphrates, and even overlying other channels. So Dr. Jaffa Jaferi conducted fieldwork here to investigate these sites in more detail, excavating sections across channels of the crevasse play and in the relic course of the Euphrates. And you can see in this very flat plain, highlighted in red here is the trace of a channel. And excavation was done to get samples for dating. So sections are excavated at 5 locations, which you can see here on the map. And 6 shells were recovered to use as radiocarbon samples. These are processed by the University of Oxford Radiocarbon Accelerator Unit using AMS, Accelerator Mass Spectrometry, and calibrated with the OxCal computer program. The bulk of the dates from the various channels sampled fall into the 3rd and 2nd millennium BC. These dates are consistent with previous investigations of Eridu. And our work suggests cultivation fanning out from the Euphrates around crevasse plays and potentially functioning for long periods of time. So the situation on northern Mesopotamia is a bit different because rain-fed agriculture is possible, but risky due to variability of precipitation, as I mentioned before. Now, we often talk about these rainfall isohyet lines, but they're not sort of fixed contour lines. They're not like an elevation line. And things can be quite variable in that zone. So to mitigate against this uncertainty, extensive areas of irrigation canals were constructed by ancient empires, abstracted from the perennial sources of water. So, for example, this map shows Iron Age through to medieval canal systems in the north, some of which may have persisted in use beyond this period. And away from surface water, such as here and here, canal systems were dug to take advantage of available groundwater. So after the Sasanian period, there may have been some agricultural decline. During a time of political change and conflict, the region was contested by the Byzantine and Islamic empires, and there were recurring outbreaks of disease and famine in the 5th to 8th centuries AD. There may have been shortages of labour as well as general disruption. Some scholars have argued that in the early Islamic period in the south, irrigation mainly reused Sasanian canal systems. However, the evidence for northern Mesopotamia and viewed as a whole, in the light of the increased data set offered by using remote sensing, sheds light on a really complex and intensively cultivated landscape. And there were state policies in the early Islamic period comprising direct intervention and water management, but also incentives to encourage other elite individuals to invest in it. For example, Kennedy describes how these encouraged individuals to bring formerly marginal lands into cultivation by providing them with tax breaks and land ownership opportunities, supporting larger cities. This may explain some of the increase in irrigated cultivation at this time. Now, in the first millennium BC, the Assyrian state constructed significant canal systems, especially along the Tigris, to support cities such as Nineveh and Ashur. Some of the canals are part of a program of construction sponsored by the Neo-Assyrian king Sennacherib in the 8th century BC. Several scholars, including and Outwill in the present study, have mapped the area in detail using corona images, showing large-scale canals of high earthen banks. These meandered through the landscape, following the contours of the landscape, with only a few traces of offtakes remaining. Suggests that these irrigation systems would have had dams, weirs, and aqueducts. In the case of a canal leading to Nimrod, a tunnel was used to transverse a conglomerate bluff. Several large canals led towards Nineveh, supplying the city as well as irrigating fields. Some of the canals are associated with stone reliefs. But moving west to the Euphrates and Syria, we can also summarise the development of irrigation in later periods. Relic water features around Jarablus, for example, were identified and visited in fieldwork until 2010, including the remains of a couple of large canals and some rock-cut channels, which are actually quite hard to see on satellite imagery and easier to map on the ground, as it turns out. An infield canal flows south for the site of Tel Jarablus Titania and was probably in use during the Byzantine and early Islamic periods. But canals have been mapped not far away in the lands up to the western south banks of the Euphrates. Some of these may be of Hellenistic or Roman date associated with Hierapolis, the modern Membridge. There are several early Islamic canals along the Euphrates which have been lost underneath dams, but which can be recorded using the historical corona images. For example, the large canal at Dibsi Farage, known as the Nar Maslama here. It's already well known for survey and excavation. It's been dated on the basis of Umayyad coins. But there was also a kanat here, which stretched for over 4 kilometres from the uplands above the site and faded out close to it. While the large-scale canal would have provided water for irrigation, the kanat may have supplied the site itself with water, and then was therefore presumably was used at the same time within the Roman to early Islamic period represented by the site. There's particularly dense irrigation on the Belik, which is a tributary of the Euphrates. You may remember this example from the beginning, a mess of channels. But when we unpick this using archaeological data as well as image interpretation, distinct systems start to emerge. The earliest well-known data canal in the Belik Valley is the Salan Canal, this little orange one here. Tony Wilkinson excavated a section in it, and the survey obtained a radiocarbon sample from the bed deposits of the later phases of the canal of around 570 AD. This date is supported by ceramics collected from overlying deposits within the canal void, and this dating information suggests that the feature was probably in use from the Hellenistic to early Byzantine period or around then. You can see it quite clearly on the corona image from the 1960s here. However, on the other side of the Belik, there's a really sophisticated canal system visible in the corona images. Unfortunately, it's mostly now been removed by modern cultivation. When we visited in 2010, there wasn't really much of it to see. The main canals, laterals and drainage channels of the canal system known as the Naro Abra are all identifiable. So you can see the channel here, a couple of different channels of it here, some still potentially partially in use in the 60s, and lots of offtakes coming off it. So like the other nearby systems, it's constrained by the flat topography of the Belik. The main canal flows along a ridge of higher ground in the middle here. An examination of the elevation model we've got shows this almost imperceptible ridge. Although the elevations involved a small, making use of the ridge allowed the canal to supply a large area despite its shallow gradient. Parts of the system were investigated by Wilkinson in 1998 by association with adjacent sites and field scatters of pottery. It was dated to the Byzantine to early Islamic era. It may have supported the adjacent site of Medinet Delfar, which is up here. By the time of the 1960s corona images, the channel appears to become meandering and silted, as you can see here. When I visited in 2010, as I said, there wasn't really any real trace of it. And you can see there's a couple of different channels, one which in the 60s looks more out of use than the other. But there are many, many irrigation systems around the town of Raqqa in the south of the Balik. Raqqa was particularly important in the early Islamic period under the Caliphs al-Mansur and Harun al-Rashid. An area of palace structures to the north seems to have been supplied by a tunnel or canal. You can see here this feature. Now it seems to originate in an open channel up here, stemming from channels that potentially stem off or abstract from the stream of the Karamuk rather than the Balik. Anyway, it seems to then go underground to cut through this area of elevated topography. So it's, in a way, it may not be a true canal, it may be a tunnel. So outside the Balik, we have other areas of dense areas of kanats. So, for example, the corona image analysis revealed a cluster of kanats below and south of the Jebel Sinjar range in the Tel Afar Sinjar plain. So Foucault, in her 1991 thesis, briefly cites historical data attesting to pre-Ottoman kanats in this region. Some of the kanats may be more recent features associated with the 1960s imagery, especially where we see a sort of cut and cover style tunnel, where, the tunnel's dug first and then covered at intervals. There's evidence throughout Iraq of infiltration kanats, conduits and tunnels channeling spring water still in use during the 20th century, although they've been declining. But you can see lots and lots of separate kanats here with associated fields and settlement sites too, really, really visible in the corona imagery. And the map, you can see their layout. So the later channels are more clearly defined than the older channels, so there do seem to be different types of kanats here. The traditional style kanats have more widely spaced shafts and they're a bit fainter, maybe a bit eroded, also disused. But some of them do seem to be associated with these settlement sites here. And you can see there's a really dense layout of them. So by the Sustanian period of the first millennium AD, large-scale state-managed canals are constructed across the plain of southern Mesopotamia, episodically repaired. Particularly notable is the Nahran Canal, which abstracted from the Tigris, but went out of use in around the 10th century AD. But as well as irrigation, land reclamation was undertaken in the early Islamic period to transform areas of former marginal areas. New cities such as Samarra required water for luxury features, including gardens and hunting parks, but also needed, of course, irrigation canals to supply cultivation in the hinterland. It's always worth mentioning when talking about ancient water management that the biggest user of water is always going to be irrigation. So Basra is another city founded in the early Islamic period. Irrigation canals close to Basra between the Euphrates and the Shatt al-Arab have been mapped from satellite images, some of which are still in use for date palm cultivation. Verkindring linked these with early Islamic systems described in medieval sources, including the ridges mentioned by Al-Tabari as created for salt clearance. Recent research by Peter Brown and another ongoing project by myself, Peter and Jafar is mapping these features in detail. The potential of bringing water inland from the Shatt al-Arab was demonstrated by the presence of at least 3 pre-Islamic canals. According to the textual sources, the first canal constructed to bring water to the medieval city linked Basra with the pre-existing town of Al-Ubula and the Shatt al-Arab. A second canal was later dug where an important harbour was located. A canal excavated in the 8th century supplied the agricultural hinterland of Basra. Texts from the 11th and 14th centuries describe an area of productive gardens and palm groves, likely watered by these canals. Peter has mapped the canals from the corona imagery in detail. A network of regularly spaced canals dividing up the land in this area is visible in the corona, in many cases preserving the layout of individual parcels of land or maybe farms. In particular, an area of linear ridge features is very visible. You can see these features here, the corona image. And here's a photo taken by Jafar during his survey. So our recent project funded by the Gerda Henkel Foundation is mapping this area of ridges using high-resolution stereo imagery and investigating them in the field using radiocarbon and OSL dating. These samples are currently being processed. The long ridges rise above the ground surface by 1 to 3 meters, typically measuring around 0.8 to 1 kilometer in length and around 25 to 50 meters in width. The ridges seem to be agricultural and associated with the canal network. It's been suggested that they could have been created by removing saline topsoil and sort of heaping it up to make that characteristic ridge. Alternatively, they could have been part of an irrigation system, representing soil removed to create depressions more easy to water for cultivation. We're working to try and address some of these questions, as well as their dating, using some hydrological modelling. We hope to be able to update everyone on the results of this programme of modelling and scientific dating soon. So, medieval water management systems remained embedded in the landscape of northern Mesopotamia until relatively recently. But since the latter part of the 20th century, the environment of Syria and Iraq has been developed. The remains of relic canals were rapidly removed between the 1960s and 1990s to make way for new large-scale schemes, which replaced, for example, traces of old former rain-fed cultivation in the north. Nowadays in Iraq, irrigation is under more management and relies on large-scale systems, including dams and canals. Studies of irrigation in the 1960s, though, showed that after the main government canal, maintenance and construction was often done by farmers, and regular cleaning is needed to maintain canals. Without maintenance, irrigation systems become unusable and fields are abandoned. Sometimes canals can become difficult to maintain, so they get replaced with an adjacent canal, and we see this in both ancient and modern times. Now, a secondary feature of such systems can be unintended consequences. For example, the outflows of many Mesopotamian canals can lead to the development of marshes. Thus, literary sources regard marsh formation as both a natural and a cultural phenomenon. Breaks in levees created in order to irrigate farms could have the consequence of causing river diversions, which would have been a disaster for irrigators downstream on an original channel. However, marshes provided important resources, including fish and reeds, and have a complex and long-term history, which I don't have time to discuss in detail today. Against variable conditions and environmental changes. The landscape we see today is the result of long-term sequences of human modification. Remote sensing in particular has allowed us to understand the layout and functioning of these systems, but there's a significant need to better understand their chronology using scientific dating. Archaeological research is only just starting to address this, and it can be hoped that future work to record past water management prioritises it. The longevity of some of these systems, in some cases thousands of years old, suggests a degree of sustainability. Given modern pressures on water resources, long-term resilience of past and traditional irrigation could be informative in achieving future sustainable development. We raised this possibility in a recent policy briefing for COP27 and propose that this continue to be explored. Thank you very much for inviting me and for listening.
Thank you very much, Louise, for this great talk.